Hello everyone, myself Vikas Desai, Assistant Professor in Electronics and Telecommunication Engineering from AISSMS Institute of Information Technology. Today we are going to learn how to design and implement 3-bit up synchronous counter using master-slave JK flip-flop IC7476. In IC7476, it contains two master-slave JK flip-flop with preset and clear pin. Here the preset pin is used to set the value to 1 and clear pin is used to set a value to 0. But in this 7476 both preset and clear pin are active low. That means if we connect a preset to logic 0, so JK flip-flop will provide output 1. If we provide a clear pin to logic 0, the JK flip-flop will provide output logic 0. The individual JK flip-flop contains the clock pin and each clock pin is a negative edge triggered. As per this pin configuration, the functional table is written on the right hand side. Preset and clear pin, if both the pins are connected to the logic 0, it will not work in a proper manner. The case 3, condition 3 as described in the table. To get an output of a normal JK flip-flop according to the truth table, we have to connect the preset and clear pin to logic 1. By considering this configuration of a 7476, we are going to implement a synchronous up counter. For this synchronous up counter, we have to first write down the present state and the next state. As we know, we have to implement a 3-bit synchronous up counter, so we are going to require a 3 JK flip-flop. An individual IC7476 contains 2 JK flip-flops. So here we require the 2 IC7476. Once we prepare the present state and next state, according to that, by considering a present state Q2 and the next state Q2, we have to implement an excitation table of individual flip-flops. So here, if I want to implement the excitation table of the flip-flop 3, that is nothing but a MSB J2K2, I have to consider the values of Q2 present state and Q2 next state. In this way, we implemented the excitation table for individual JK flip-flop. Then the next step is we have to implement a K-map to find out the expression for J2K2, J1K1 and J0K0. So this is the K-map for J2. By considering a J2 column, whichever value is 1, according to that we have to keep it into the K-map. As we know, when the don't care helps to make a group of ones, we have to consider that don't care as a 1. So by using that knowledge, we make a group of ones column wise, which is gray shaded. As we know, this single group contains 2 rows and 1 column. Between these 2 rows, the Q2 value is changing from 0 to 1, but from the column there is no change in the bits, so we have to consider as it is Q1 and Q0. So the J2 equals to Q1 and Q0. Similar way, the K-map for the K2, and it is exactly similar to the J2, so same way K2 equals to Q1 and Q0. Next one is expression or K-map for the J1. Here 2 ones are available, but nearby that a don't care condition is also there, so grouping of 4 ones is possible, and out of that 2 rows and 2 column, only 1 bit is unchanged, that is nothing but a Q0. So J1 equals to Q0. Same way K1, again K1 is quite similar and exactly similar to the J1, so also K1 equals to Q0. To continue this, the expression for the J0 will be here. J0 column contains all 1 or don't care. By considering that, it will makes a grouping of 8 ones, so equals to J0 equals to 1. And similar, K0 is also quite similar to the J0, so also K0 equals to 1. So by considering these expression values J2 K2, J1 K1 and J0 K0, this is the logical diagram. As I said, for the normal operation of a JK flip-flop, we have to consider the preset and clear pin to logic 1. Here, as a logic 1, we are connected the preset and clear pin to the VCC. This is a synchronous up counter, that means a synchronous logic. So all the individual flip-flops is connected to the same source of a clock as shown here. Next, the J2 input is connected to the output of a AND gate, and AND gate is connected to the Q1 and Q0. That means the output of a J1 K1 flip-flop. In this connection, the Q2 output pin will act as a MSB and Q0 output pin will act as a LSB. Then J1 K1 is connected to the Q0 as we derived from the K-map. It is shown here, and J0 K0 is connected to the logic 1. Here logic 1 we are connected to the VCC. So this is all about the synchronous up counter using IC 7476. Thank you.